Here's a piece of equipment that would have made old-time ironworkers absolutely green with envy: the Ockbend APK 240 Profile Bending Machine. If you've ever tried bending structural steel by hand or with traditional press brakes, you'll appreciate what you're about to see. This Turkish-built marvel can take straight steel profiles, I-beams, channels, angles, even hollow sections, and curve them into precise arcs without breaking a sweat. The APK 240 uses 3 powerful rollers arranged in a pyramid configuration, and here's where it gets interesting. These aren't just dumb rollers. Each one is driven by its own hydraulic motor and monitored by digital encoders that track position down to the millimeter. Watch as the operator feeds this steel channel into the machine. The bottom rollers provide support, while the top roller applies downward pressure. But here's the clever part. The machine can adjust the pressure dynamically along the length of the material. You'll notice there's no springback, no distortion. That's because the APK 240's computer has already calculated the exact overbend needed to compensate for the steel's natural tendency to spring back to straight. The hydraulic system generates up to 240 tons of force, controlled with the finesse of a watchmaker. See how smoothly that curve develops? The operator can program complex radius changes, creating compound curves that would have taken days of heating, hammering, and checking with templates in traditional shops. Now this is where manufacturing technology really starts to feel like something out of a high-tech workshop. The Integrex i200S is what we call a multitasking machine. And folks, it's a marvel of Japanese engineering from Mazik, a company that's been pushing the boundaries of machine tool technology since 1919. What makes this machine special is its ability to perform turning, milling, drilling, and boring operations without ever removing the workpiece. Think about that for a moment. Back when many of us started in manufacturing, you'd turn a part on a lathe, then move it to a mill, then maybe to a drill press, each transfer introducing tiny errors that accumulated. The i200S eliminates all that. At the heart of this system is the Vortex configuration, a lower turret that can position 12 different tools, and a milling spindle that can tilt and rotate in multiple directions. Watch how the workpiece spins in the main spindle, while the turret tool cuts the outside diameter. See that precision? The machine maintains tolerances of 0.0001 inches, which is absolutely critical for aerospace and medical components. Now here's where it gets really impressive. The machine pauses the main spindle rotation, and that milling head swings into action. It's drilling cross holes, cutting keyways, and milling flats, operations that used to require completely different machines. The thermal compensation system continuously monitors temperature and adjusts positioning to account for metal expansion from cutting heat. The i200S can handle workpieces up to 8 inches in diameter and 30 inches long, with the Y-axis capability allowing off-center operations that old-school lathes could never dream of. That ball screw-driven system you're hearing? It's positioning the cutting tools with repeatability that ensures part number 1000 looks identical to part number 1. This technology is particularly valuable for small batch production and prototyping, exactly the kind of flexible manufacturing that keeps American machine shops competitive. Companies producing complex components for industries like oil and gas, defense, and medical equipment rely on machines like this to deliver parts that simply can't fail. There's something primal and powerful about watching a forging operation. It connects us directly to thousands of years of metalworking heritage, yet what we're seeing here at Manan Shahid Forging represents the cutting edge of modern manufacturing. This is heavy industry at its finest, producing the critical components that keep our vehicles, machinery, and industrial equipment running strong. The process begins with raw steel billets, heated in massive furnaces to temperatures exceeding 200 degrees Fahrenheit. Watch that orange-yellow glow. That's carbon steel at its most malleable state. The forging crew uses automated tongs to transfer the glowing billet to the forge press, and here's where the magic happens. That press can generate over 5,000 tons of force, enough to reshape steel like it's putty. For crankshafts, those crucial components that convert piston motion into rotational power, The process requires multiple strikes in specially designed dies. See how the first blow creates the rough shape? The metal flows into every contour of that die cavity, the grain structure aligning to follow the part's geometry. Each hammer blow is precisely controlled. Too little force and the die won't fill completely. Too much, and you'll create defects. The forge masters here have years of experience reading the metal's behavior, even though modern sensors and computers now assist them. Watch the gear blank being formed. This is what we call impression die forging. The steel literally erupts around the edges, forming flash that gets trimmed away later. That flash isn't waste. It actually serves a purpose during forging, helping to ensure complete die fill and maintaining proper pressure. After the initial forging, parts move to trimming presses that shear away excess material with 500-ton punches. Then comes heat treatment. Parts are reheated and carefully cooled to achieve the right hardness and toughness balance. For axle shafts, which endure tremendous twisting forces, this heat treatment is absolutely critical. Those crankshaft journals need to be round within 0.0005 inches, with surface finishes smooth enough to support oil film lubrication for hundreds of thousands of miles. Here's something that beautifully blends old metalworking traditions with modern automation: the Primo 600 wire and profile forming machine. The Primo 600 feeds the wire through a series of precisely engineered stations. First stop, edge forming. Watch how those hardened steel rollers gently compress and shape the wire edges, creating clean, uniform profiles. Next comes the decorating station, where embossing rollers imprint patterns or textures onto the wire surface. The rollers are synchronized to run at the exact same surface speed as the wire, preventing any scratching or smearing. Now here's the really cool part: the twisting mechanism. The machine can rotate the wire along its longitudinal axis while it's moving forward, creating those elegant spiral patterns you see in decorative railings and furniture components. Finally, the hemming station folds and crimps edges with remarkable precision. Those hemmed edges eliminate sharp points and create stronger, more rigid profiles, essential for safety and structural integrity. You know, there's something almost mesmerizing about watching precision machinery at work, especially when you realize the technology we're seeing today would have seemed like pure science fiction back in the 1970s and 80s. What we're looking at here is the Heller CP8000, a 5-axis milling and turning center that's revolutionizing how manufacturers produce worm gears, those spiral tooth components that have been the backbone of power transmissions since the Industrial Revolution. Now, for those of us who remember when CNC machines first started appearing in American factories, this is truly next-level stuff. The CP8000 combines what used to require 3 or 4 separate machines into one seamless operation. It starts with the raw metal blank being loaded into the chuck. You'll notice how the workpiece is gripped with incredible force, yet positioned with tolerances measured in thousandths of an inch. The magic happens with those 5 axes of movement. Unlike the old 3-axis mills many of us worked with, this machine can rotate and tilt the cutting tool simultaneously while the workpiece spins. Watch how the carbide cutter approaches the blank at that precise angle. That's the machine calculating the exact helix angle needed for the worm threads. The spindle is running at around 3,000 RPM, while a constant stream of cutting fluid washes away metal chips and keeps everything cool. What's fascinating is the interpolation happening here. The computer is coordinating all 5 axes in real time, carving out those intricate spiral grooves that mate perfectly with a worm wheel. Back in the day, master machinists would spend hours setting up a hobbing machine to cut gears like this. Now, the CP8000 does it in one setup, maintaining precision within 5 microns. That's about 1/10 the thickness of a human hair. The finishing pass you're seeing now is where the real artistry happens. The machine automatically switches to a finer cutting tool, and you can see how it burnishes the surface to a mirror finish. This isn't just about looks. That surface quality directly impacts how efficiently the gear will transmit power and how long it'll last. Companies like Siemens and Bosch rely on machines like this to produce components that'll run smoothly for decades, just like the quality American manufacturing we've always taken pride in.